The question reads graph. So I'm going to use the procedure that's laid out in the notes to graph this rational expression. First thing, I want to know if there's any symmetry. If I have any kind of symmetry, I only have to do half the work. So I want to know this. To test for symmetry, I plug in a negative x. So I have the opposite of x, quantity squared, over the opposite of x, quantity squared, plus the opposite of x, minus 6. As I work this out, I have x squared on top over x squared on bottom minus x minus 6. It does not match the original question, nor is it the complete opposite with all the signs different. So unfortunately, I have no symmetry. So I have to do this question all the way, all the work. I'm going to go ahead and try to simplify this, which is going to be basically factoring my denominator so I don't have to do it later. To factor, I have x plus 3 times the quantity x minus 2. I need factors of 6 that if I subtract give me a positive 1 over x squared. Now I'm going to find my x-intercepts. If I have any, of course. To find the x-intercepts, I set the numerator equal to 0. So x squared is equal to 0. If I take the square root of both sides, of x is equal to plus or minus 0. It's the same point because it's 0. So my only x-intercept is the point 0, 0. Now I need to find my y-intercept for cases where I don't already know the answer. I know the answer because my x-intercept is 0, 0. My y-intercept is also going to be 0, 0. To find the y-intercept, I plug in 0 for x. So I have 0 squared over 0 squared plus 0 minus 6. That's 0 over negative 6, which is 0. So my y-intercept is the point 0, 0. Now I need to find any vertical asymptotes. So I set my denominator equal to 0. So x plus 3 is equal to 0. X minus 2 is equal to 0. So we know x is a negative 3, x is a positive 2, and those are my vertical asymptotes. I need to find my horizontal asymptote. I should only have one. And I use my degrees of my question. My n is equal to 2. My m is equal to 2. Those are my degrees in my original question. Since they're equal to each other, my y-asymptote is y is equal to 1 over 1 or just y is equal to 1. I would also like to know if I have any holes. For this question, I have no holes because nothing completely canceled out in my original question. So I have no holes. Let's see what we have already to determine what extra points I need to find when I graph this. So I have a nice sheet of paper I've already lined up and have labeled. And I'm using the information I have found earlier and graph that information. So I know I have no symmetry, which makes me sad, but it's workable. Okay. I know I have an x-intercept at 0, 0, as well as y-intercept at 0, 0. So I'll mark that. I have a vertical asymptote at x is negative 3. And I'll make that a dashed line because it's not really part of the graph. It's where my graph is actually undefined. And we have a vertical asymptote at positive 2. Once again, I'll make that line dashed because my graph really doesn't exist there. We just want to know where that is so we don't touch or cross it. I also have a horizontal asymptote at y is 1. I'll make this one dashed as well. My graph could possibly be defined there. It's just kind of telling me the end behavior of my graph as x increases without bound, as we say. So what we've come up with thus far is that we got 1 point. I don't know what's happening there. Nothing's being connected. All I know is I have that 1 point. Okay, which means I'm going to have to plug in points to figure out what is going on everywhere else so I can connect the dots and make my graph. So I'm going to look at my graph. That's all I have. I'm going to pick points that are going to be less than my smallest vertical asymptote, numbers in between my vertical asymptotes, and numbers greater than my vertical asymptote. And as I'm going to pick the numbers I'm going to plug in. So we're going to plug numbers into the original question called f of x. So I'm going to pick numbers. Let's take f of negative 8. It's a number less than negative 3. So I'm starting with negative 8. And I get 1.28 when I plug it into the original question, into f. I'll take negative 7. And that gives me about 1.36. I'm going to find f of negative 6. Gives me about 1.5. F of negative 5 gives me about 1.79. F of negative 4 is 2.67. And -3 doesn't exist because that's my vertical asymptote. So I'm going to try numbers in between my vertical asymptotes now. I'm going to plot these first. Okay. So, taking the point -8 is right here. And they tell me 1.28. So I'll say right about there. I have the point -7 at about 1.36. I'll say right about there. -5 was about 1.5. I'll say there. -5 is 1.79. So I'll say right about there. -4 was positive 2.67. So I'll say about there. I know my graph cannot touch across my vertical asymptote, so my graph is doing something like that, just by point plotting. Now let's try to find numbers in between my asymptotes. So we're looking for f of -2, plugging that into the original question. I have -1. I have f of -1. I have the opposite of 0.17. I don't need to test 0 because I already know what my y and my x-intercept are. So I'm going to do f of 1. And the opposite of 0.25. I don't do f of 2 because f of 2 is a vertical asymptote. So I'll plot these 3 points with my y-intercept and see what happens. F of -2 was -1, so it's right here. F of -1 is -1.717. It probably should be a little bit closer. We'll say right about there. 1 was about -1/4, -1/4. It's about there. I know my graph cannot touch or cross my vertical asymptote, so it's going to follow that pattern, something like that. Now I need to find numbers that are greater than 2. So we find f of 3, and that's about 1.5. Find f of 4. That's about 1.14. Take f of 5. It's about 1.04. Find f of 6. Gives me exactly 1. F of 7 gives me 0.98. Just because I'm curious, f of 8 will give me about 0.97, so it starts to even out right about there. So I will plot these points onto my graph. So 3 was 1/2, 1.5, so right about there. 4 was about 1.14. 5 was about 1.04. 6 was exactly 1. 7 was 0.98. So we'll say it's right about there. And we can see where this graph is heading. It may even come back up if you go out far enough. But my graph is coming up because it's a vertical asymptote. And that is the graph of a function.